don't, thank God, no doctor put a special name to the disease of this condition. They just say the people who have deficiency of terminal components of the complement protein, they are more vulnerable to the gram-negative bacterial infection, more specifically about Neisseria bacteria. Of course, there are two groups, gonorrhea and gonococci and meningococci. Is that right? Am I clear? But gram-positive bacteria they handle well. You want to know why? It means killing in gram-positive bacteria through the complement system may not be requiring this thing, even remaining this component up to this can manage the gram-positive. Should I tell you how? Okay. Actually, there is one more function of complement system. Up to now I just told you that complement system in this given example has produced membrane attack complex and damaged the physical integrity of bacterial lipid membranes. Am I clear? But it's not necessary you drill holes into your enemy. Do you think if you tie your enemy with the loin, and loin will eat up the enemy? This is one more way how complement work. Let me tell you how. Let's suppose this is a gram-positive bacteria. Of course, it must be weeping, isn't it? Why? Why? Because complements have attacked. Why? Because antibody bind here. This bacteria is attacked, marked by the antibody. Antibody tail become active. Now you will tell me who will bind here? C1, and that will activate which one? C4, and what will remain there? C4b, and what will go away? C4a, and then what will bind here? C2b, and what will go away? Another apple, which is C2a. Is that right? And these two are called C3 convertase. So they will activate what? Yeah, C3b, and what another apple will go away. What is that? C3a. Right? Now you can say this bacteria is hooked with C1. Actually, bacteria was chained by the antibody. Tail of the antibody activated C1. C1 bound C4b and 2b, which activated C3b. So all these are sticking to what? Bacteria. Is that right? Now, what happens? That all of them are sticking together on the surface of bacteria. Am I clear? Is that clear? No problem? Now, who are the dangerous loins which eat up the bacteria? Neutrophil then? Macrophages. Neutrophil then? Macrophages. They love to eat up bacteria. They eat up the particulate matter, particles. Look, imagine here is a neutrophil or macrophage, and it is trying to eat this bacteria. Whenever it tries to eat bacteria, bacteria may slip out of its mouth. Is that right? But in it, it has a special pocket with which it can bind with C3b. But there is no complement bind with it. But look at another bacteria. This is a bacteria. This is a bacteria with C1, 4b, 2b, C3b. So C3b is there. Now, okay, A components will go away. Who is here? Macrophage. Actually, this portion of this is a special protein which is expressed on the neutrophil than macrophages, and this protein loves to stick with C3b. You get it? So if any bacteria is unfortunately having C3b attached with it, and this touch any neutrophil or macrophage, can this run away? It cannot run away. It's just like that I tie you with a very big dog with a chain. Chain consists of especially C3b. And now can you run away? Dog is there with you, isn't it? This is a special function of C3b. The C3b has receptors on the neutrophil and macrophage membranes, and whenever neutrophil or macrophage find a bacteria attached with C3b, right? So C3b will activate the receptor. This is called C3b receptor. This gives very powerful signal, gives a very, very happy signal to the macrophage internal side. Congratulations, we have a bacteria which is loaded with C3b, it will never go away, let's grab it. Super opportunity. I say simply, C3b enhances the phagocytosis. Bacteria can be phagocytosed without C3b, but slowly. If there are 10 bacteria here, without C3b, they will be phagocytosed slowly. But if there are 10 more bacteria, and on their surface, what is this? C3b molecules. C3b on one side are holding with the, sticking to bacteria, other side they can stick with the neutrophil or macrophage. It is just like bacteria now find, neutrophil or macrophage now find bacteria which are having the jam on it, and they will be eaten up very deliciously. Are you understanding it? Yes. Am I clear? So we can say C3b facilitate the phagocytosis of bacteria. Is that right? Any molecule which facilitate the phagocytic process is called opsonin. What is the definition of opsonin? Opsonins are those molecules which on one side can bind with bacteria, on other side can bind with neutrophil or macrophages and hold the bacteria and neutrophil or macrophage together, and they facilitate the process of phagocytosis. So it means opsonin molecules amplify the phagocytic process. One of the opsonin molecules you right now know is C3b. There's one more you are supposed to know. Excellent, IgG. One of the antibody, look here. Now I will tell you something interesting. Let's suppose this is a very happy bacteria. Why? Because it does not have opsonin attached with it. If neutrophil try to eat it, it may fool that. Is that right? And neutrophil is really worried what is happening to it and having a lot of sweat to eat it. Right? Very sad neutrophil, having tears. Opposite to that, here are two neutrophils which are very, very happy. Is that right? There is one neutrophil here and there is one more neutrophil here, very, very happy. You know why they are happy? Because this bacteria is very sad. And why this bacteria is very sad? Because it has sticking to it C3b. On one side it stick to bacteria, on other side it is sticking to the neutrophil. So it will be sure eaten up. Another is that another bacteria which does not have C3b but still very sad. Right? Why? Because it has antibody, especially IgG. IgG on one side bind with the bacteria, other side its tail become active as soon as it bind with the antibody. Either it will activate the complement system or it may interact directly with the receptor of neutrophil or macrophage. And this receptor is for which one? Which molecule? Fc portion of IgG. So it means neutrophil and macrophage have receptor for, neutrophil or macrophage have receptor for C3b receptor, as well as they have receptors for on their surface, Fc portion of IgG. Right? So any bacteria which is coated with C3b will be caught very effectively, or any bacteria which is